Okay, now already we have discussed about the term spectrum and the dispersion of light. Okay, now let us come to the pure and impure spectrum. Okay, the two things we will discuss about the pure and the impure spectrum. Okay, now in a spectrum, since it is known as the band of colors which are obtained on the screen. Okay, after dispersion, whatever the light which has been obtained on the screen, that band of colors we call it as a spectrum. And the spectrum can be as a impure spectrum, and other one is a pure spectrum. So in impure spectrum, also what happens? The spectrum do not have a well-defined sharp boundaries. They do not have well-defined sharp boundaries, but they will merge the rays of light, the colors of the light will merge with each other. Okay, example, now let us consider here. Now this part, this is the source of light. Okay, source of light coming from the light source. Okay, light coming from the source, and this is the prism, and this is the screen. Now a white light from the source, it comes and it falls on the prism. Falls on the prism. And when it falls on the prism, okay, now the seven different colors of light, okay, when they fall from the prism, okay, when it come out, okay, and the light when it falls up on the screen, all this light do not follow a definite path. Okay, they do not follow a definite path. That means they do not have about a well-defined sharp boundary. Well-defined sharp boundaries means, like for example, we take a violet traveling in one direction, red light traveling in one direction. Okay, so what particular direction should be there, but it doesn't happen in the impure spectrum. Okay, so what happens is that now this ray of light, you can see here, this is the red light, this is the violet light. Okay, and the red light is merging with the violet light here. That means they are not following a definite path. They are not following a definite path. Since they get overlap, they merge. Merge means they get overlap. So when the two colors get overlap, or more than two colors get overlap, okay, so then the spectrum which you find it on the screen, okay, the band of colors which you find it on the screen, that we call it as a impure spectrum. So the impure spectrum means the spectrum which do not have well-defined sharp boundaries and merges with each other, with one another, they are known as the impure spectrum. Is it clear? Next one, pure spectrum. Now the pure spectrum, just opposite, they have a well-defined sharp boundaries and they do not merge with one another. Okay, the light will not be able to merge with one another. That means they do not get overlap. So that means this pure spectrum, you can get it by a device, by instrument known as spectrometer. Spectrometer is an instrument which you can get pure spectrum. So pure spectrum you can get by using a device, by instrument known as spectrometer. Okay, so now this is the pure spectrum. Now this pure spectrum you will find it in a spectrometer. Okay, with the help of spectrometer you can find the pure spectrum, and here is the diagram. So this is the arrangement. This kind of lens are there. First of all, a convex lens is used here. Okay, and the prism, and again other one is the convex lens. Then this one is the screen. Okay, understood? So what happens is that now this S, I have written here S. S means a shield, a small hole. Okay, a small hole is made here, and through that hole, okay, the rays of light can pass. That means I have drawn two rays of light here. That means one is the red light, this is the red top one, and other one is the violet. Okay, so number of rays of light can pass. Is it or not? Because always the white white light is a combination of the seven different colors. Okay, but this S denotes the shield. Okay, shield means the aperture. Okay, and through the shield, the rays of light will pass through, okay, through it, and it falls on the convex lens L1. This is the convex lens, considered as L1. And when it falls on the prism, what will happen? The beam of light is parallel. Now this rays of light goes parallel. So actually this is the beam of light, okay? It's not a ray, I have drawn two rays, so it becomes a beam here. So the beam of light goes parallel after falling on the convex lens. And we know that convex lens is known as a convergent lens. Convex lens is known as a convergent lens for the converging lens. Why? You know? Because the rays of light after refraction they will actually converge, they will actually meet. Okay, so this is the convex lens here. So when the light rays it falls on the convex lens, from the convex lens it goes parallel and it falls on the prism here. Okay, when it falls on the prism here, then again from the prism what will happen here? The rays of light will passes through it. Okay, the same ray of light. Okay, so since the rays of light will passes through it, then after that what will happen? Again on the other side, again another convex lens is here. Okay, so from the prism again it falls on the convex lens, and here is the screen, and on the screen you will find the one particular light only. So then this will become as a red light, and this is the violet light. So that means number of light rays can pass through the cylinder. Okay, but here I consider only the two rays of light, that is red and a violet. So to see the pure spectrum, we have to consider the source of light. Okay, should pass through the aperture, through the cylinder, should fall on the convex lens, and after that prism is kept here. Okay, and from the prism also the rays of light again it comes out. Okay, then it falls on again another convex lens, and through the another convex lens it falls on the screen. So when it falls on the screen, now these rays of light, now this light will form a well-defined path. Okay, so they have got a well-defined boundaries. That means the rays of light will not get overlap. But they do not get overlap, but they will form a well-defined boundaries. Okay, and the rays of light will not be intersect, or they do not merge with each other, and you will find a particular rays of light on the screen. Okay, so you will see only the red light, only the violet light, or any other light you can see. Is it clear? But whereas in a impure spectrum there is a overlapping of colors, red and violet. Okay, so they get overlap. One color gets overlapped with the other. So they do not follow a definite path in a impure spectrum. But whereas in pure spectrum, you can find the rays of light will follow, the spectrum will follow a definite path. Okay, they have got a well-defined boundaries, and the light rays will not get overlapped with each other. So they are known as the pure spectrum. Is it clear? So this is about the impure and the pure spectrum. So the next point, okay. The next one is here, that is he made an experiment to show that prism itself do not produce any color. Prism themselves do not produce any color. You know that prism, they are not producing any color. Okay, so when the white light will fall on the prism, that white light get dispersed, and you will find the 7 different colors. And that 7 different colors is not created by the prism, remember that. It is not produced by the prism. That white light is that 7 different colors is produced by the white light. When the white light get separated, when they get dispersed, that white light will be divided into 7 different colors. And that 7 different colors is produced by the white light, not by the prism. Okay, and another point is also here, when you combine the 7 different colors, you will get the white light. Okay, so the two conditions are there. One condition is, when the white light gets dispersed, you get the 7 different colors, starting from violet and ending at red, lives on. Okay, and when you combine that 7 different colors, you will get the white light. So this is also done by this experiment is also done by the Sir Isaac Newton. What he did is that he took a disc, okay, and he divided the disc into 7 different sector. This is known as a sector. 1, 2, 3, 4. Okay, he made up into a sector. He took a disc, divided into 7 equal parts, and he painted 7 different colors there. Okay, violet, indigo, blue, green, orange, all this we color. Then after that, now that disc is rotated now. Okay, that is rotated. So when the disc is rotated slowly, you can easily differentiate the 7 different colors. You can easily rotate it. But when the disc is rotated at a very high speed, when they are rotated at a very high speed, then when you see from a distance that rotation of that disc, you will not be able to visualize the 7 different colors. Okay, you will not be able to see the 7 different colors. Though the 7 different colors are painted in the sector of the disc, but you will not be able to see the 7 different colors because of the high speed rotation of the disc. And and what you will observe is that you will observe a white disc only, a dull white appearance you will see. Okay, dull white appearance you will see. So that means when the disc is rotated at a high speed, that 7 different colors get combined together. And when the 7 different colors get combined together, you get the appearance of a white light. Okay, and when that white light gets separated, you get the appearance of the 7 different colors. So therefore, we can say that the white light, when you combine the when you combine the 7 different colors, you will get the white light. Okay, and when you disperse the white light, you will get the 7 different colors. Is it clear? So therefore, we can say that the prism themselves do not have colors. And also, Newton also followed this. Newton, he made an experiment that to show that prism by itself produces no color. Prism itself do not produce any color. That means they don't have any color. So follow this diagram. Okay. So for this, you will take a white light from the cardboard. So there is a cardboard here. Okay, and you make a small hole in the cardboard. This we call it as a sill here. Okay, a white light, you take a cardboard, okay, and the source of light is kept just behind the cardboard here. You make a small hole here, and through that hole, the white light will pass through the sill. When the white light will pass through the sill, it falls on the prism P. Okay, P is the prism here, and this prism is kept erect. Erect means it kept in an upright position. Erect prism is there. And this white light, when it falls on the prism, okay, what will happen here? Now this light will, and this is the screen here. AB is the screen. When the white light will fall on the prism, what will happen? Dispersion of light takes place here. The light gets dispersed. And when the light will get dispersed, you will get the 7 different colors on the screen. Is it clear? Understood? 7 different colors is there. Then again what you do is that, now on the behind the screen again you take another prism. That is, let us consider this as P2. This is as P1. Consider as P1 and P2. And this prism is kept in inverted position, upside down. Inverted means the base will face upward and the tip of the prism will fall down. It's inverted position. Okay. Now on the other side again you keep the screen here. Now what happens is that, now here on the screen already what are there? 7 different colors are here. Okay, because the dispersion of light is taking place here and this is the spectrum. But what we have to prove, what Newton has to prove, he has to prove that prism themselves do not produce any color. Okay. Now again on the screen a small hole is made. This one is the hole. This non-one which I have made here, this is hole X, which is denoted as capital letter X. Okay, and through that hole, okay, through that hole the 7 different colors are here, and these 7 different colors, by making a small hole on the screen here, let us consider, when you make a hole, let us consider only through that hole only one color of light can pass through the hole. Let us take green light. Other light also it can pass, okay, red, violet, any other color, okay, but through that hole only green color can pass. Okay, one color light can pass. And when one color will pass through that hole, through the hole made on the screen, again it falls on the another prism which is kept inverted. Then this ray of light will, through the prism again, it falls on the prism, and from the prism again it goes towards the screen. When it goes to the screen, you will get only the green color. No any other color. If the prism could have been produced the light, the color, I will say, if the prism could have been produced a color, then on the green, you can see other colors also, violet, indigo, orange, red. Okay, other colors, other 7 different colors also can be seen here. But prism themselves is not producing light here. Okay, so then if the green color is allowed to pass to the screen, okay, and falls on the prism here, only that color it is observed. It is, you can see that. If it is allowed to pass red color, only red color can be seen, no any other color. So this experiment shows, okay, that the prism itself do not have any colors. Is it clear? Understood?